Geeks for Geeks has a challenge for you, the 390 challenge. Choose what you want to learn in 2024 and aim to complete at least 90% of the course in the next 90 days. And if you do that, you get back 90% of what you paid for the course. We believe you can do that. Now all you got to do is commit to your success, commit with Geeks for Geeks.
Hello students, welcome back to our YouTube channel Geeks for Geeks Gate Computer Science. So just let me know, just give me a quick thumbs up in the chat section if everything is fine with my stream so that we can start our today's session, which will be on the second session on machine learning. Just give me a quick thumbs up in the chat section, guys. Just a minute, let me check. Okay, thank you so much. Okay, I am audible and properly visible. So guys, as you have seen that we are having our 390 challenge, and in this 390 challenge, if you complete 90% of the course in 90 days, then you will get 90% of the money you have paid for the course returned back to you. So isn't it amazing? So what are you waiting for? So you have to apply for that course from 1st of January to 31st of January. Then you will get the complete refund for that course, 1st of January to 31st of January. If you will buy any course in this time from 1st January to 31st January, if you will complete 90% of the course in 90 days, then you will get 90% of the amount back which you have paid for the course. So what are you waiting for? If you do not want it, then either it is your siblings, colleagues, or friends, anyone who wants to buy a course from GFG, you can take it from that, and this will give you motivation to complete that course in 90 days, right? And you have to complete that to get back the refund value. Okay, so I hope all of you can take benefit from this challenge. So just try to take the benefit of this challenge, and as soon as you will complete the course, you will get all your money back. Okay, yeah. So just apply for it, and you can update us on LinkedIn so that we can track your how you are doing in the course. We can get to know that. Okay, so yeah. So today's session is on classification. So yesterday, in the previous class, we have discussed that machine learning are of three types: supervised learning, unsupervised learning, reinforcement learning. Right? In supervised learning, we have discussed that there should be a label data. Right? We know that what would be a output value. If I have some input features and I have output value, then I'll consider that as a supervised learning. Then I have a unsupervised learning in which I have unlabeled data, right? I do not know what would be the output. So in this kind of data, we usually form clusters and try to classify the data. And similarly, then we have a reinforcement learning in which we do not have any data. We basically machine learns by itself by making experiments like winning or losing by deciding according to that. Right, now let's come back to the supervised learning. As I told you that in this I have input feature, and with the help of that I'll get an output. So in the previous session we have discussed all about regression. I told you that regression has a numerical output, right? If I have a numerical output, then I'll consider regression for numerical output. We already have discussed that. I'm just giving you an overview. Right, now in classification, if I have a categorical output. Categorical output means that either win or loss, yes or no, A or B. These kinds of data are my categorical data, first, second, third class. So these type of data are my categorical data, which will comes under classification algorithm. So we'll see that how we'll work on these kinds of data using classification in this session. Okay, so at any point of time you feel like there is any doubt, just let me know in the chat section. Okay, yeah. So as what we just remember what we have studied in linear regression, because I am going to use that in classification algorithm as well, which The first algorithm of classification is logistic regression, which comes using linear regression, right? So what we have done in linear regression, so if I'll talk about linear regression, I have made w dot x plus b. I have added a weight with this x variable and added a base, right? Bias function, we can also say that. So this all we have discussed. So let's see, right? So what is logistic regression? So if, let's say, if I have a uh, if I have two type of output value, either I can say a or b, or positive or negative, potential customer or not potential customer, these kind of problem comes under so many times in marketing and all those things. So that's why we have this type of data, very important. So we know how we have to know how to work on this kind of data. So let's say if I have this data, I have plotted this data point using x-axis and y-axis, and I have seen that either I am getting a zero value or I am getting one values, right? Now I want to know that if I do not know anything about that data point, how do I classify that either it is a zero or it is a one? Because my output is two values only, either zero or one. Now I want to know that which of the value is zero, which of the value is one. So I have studied in previous class that I'll apply linear regression if I have some data points. So what I have tried to do, I tried to plot a line here, right? So as you can see that I have plotted a line which is z is equals to w into x plus b, right? This is a line. You can see that z is equals to wx plus b. I have plotted that line, but you can see that if there would be any outlier, this line would deviate. Let's say if I have any point here, then this line will completely deviate, right? And let's say, and there may be a possibility that this z value comes, if I'll solve w into x plus b, there may be a value that would come 16, 18, 20, 19, right? Then how do I classify that it is 0 or 1? I would not be able to classify, right? So that's why linear regression does not work here in this case. When we have categorical output, then linear regression does not work. So we want new regression, that is logistic regression. So one thing is that what we can use here, that this fw comma b, that this z line, if z is less than 0.5, then z is equals to 0. If z is greater than 0.5, then z is equals to 1, if I'll classify that. But there may be a possibility that I'll get some point here. Then how do I classify that? Either it is 0 or it is 1, right? So I would not be able to classify that. So that's why I need some new kind of algorithm, because linear regression is not working on this kind of a data set when I have a categorical output. So let's see what I can do here. So why we need new type of regression? Outliers deviate our best fit line. Output can be greater than 1 and less than 0. Then how do I know that it is taking value 0 and 1? So for that I have this type of a function. What would happen? I have a function that is z is equals to wx plus b. I'll take this z value. I'll take this z value which will under a function which we call as a sigmoid function, right? I'll take all the values which I get using this wx plus b under this function, sigmoid function. We'll get this value, something like that. We'll get this curve, and this curve has an equation 1 upon 1 plus e to the power minus z. And now you can see that whatever value z can take, whatever value this z value can take, this value lies always between 0 and 1. Why it would lie between 0 and 1? You can see that e to the power minus z is always greater less than equal to, it is always greater than equal to 0, right? And this value, if you will discuss about the graph, right? Either z can be minus infinity or z can be infinity. If z is infinity, e to the power minus infinity is 0. Either z can be minus infinity, so it would goes up to infinity, right? So you can see here that this e to the power minus z, because in numerator in numerator we have 1, and e to the power minus z is always greater than equal to 0. So 1 plus e to the power minus z is always greater than equal to 1. So can I say that 1 upon 1 plus e to the power minus z, if I'll take it to the denominator, it is always less than equal to 1. And this value, in this all the values are positive, 1, e to the power minus z, and 1. So I can say that it lies between 0 to 1, right? So this sigmoid function, what it does, the main problem it is solving, that because output can be greater than 1 or less than 0, right? So it is taking the output, it is making the output between 0 and 1, right? And one problem we were facing, that outliers deviate our best fit line, right? So what is happening here again, we are getting a curve which will help us to get either value 0 or 1. We do not know, we do not required that any best fit line which will deviate, right? Here we do not, we have worked on the problem that we were facing. Okay, so that's why we get that this sigma z, I can say that this sigma z lies between 0 and 1, right? So for what first we'll do, we'll draw a line, z is equals to wx plus b, I'll transform it into sigma z, we'll get this curve, right? Now what this sigma z does, let's see about this sigma z. Now this is a sigma z function, and this output lies between 0 and 1, 0 and 1. This sigma z gives me the probability that y is equals to 1. Let's say we have two output. Now first of all, we are discussing about binary classification. I'll discuss about multi classification as well, but right now let's first discuss binary classification. What does binary classification mean? That we only have two outputs, either 0 or 1, a or b, positive or negative, not a potential customer, potential customer. So these kind of outputs, when we have only two outputs, then we consider this as binary classification. So right now I'm working on binary classification. Binary classification. Right? So how does binary classification works? So this sigma wx plus b, or I can say that this sigma z, where z is wx plus b, it would give me the probability, it would give me the probability of y becoming x such that x is given, data points are given. So sigma z means that probability y is equals to 1. Or if I'll talk about potential customer and not potential customer, probability that y is a potential customer, y is equals to positive. So all these things gives by this probability sigma z. Now if I want to find out a probability that y is equals to 0 given x, how do I find out the probability? Guys, anyone, how do I find out a probability that y is 0? Because I have only two output here, either 1 or either 0. Just tell me guys, what would be the probability? So can I write down this as 1 minus sigma z would be the probability y is equals to 0, right? Because we only have two outputs. So let's say if this value, if we get sigma z is equals to, let's say 0.8, so you can see that we have this as a larger probability of getting y is equals to 1. Let's say for any x data point, we get the probability 0.8, right? So that means this x value is positive, right? This win the game, or this will be 1. Output would be 1 here for this x, right? Let's say for a particular x, I'll get the sigma z value as 0.2. So you can see that this is very less. So for this, 1 minus sigma z would be greater. So for this, 1 minus sigma z, that would be 0.8. So you can see that here it is what? Probability y is equals to 0 given x. So probability y is equals to 0 is greater. So I can classify this point as the output is 0 for this point. So now you can understand what this sigma is doing. Sigma is giving me the probability so that I can define that this is equal to 1 or this is equals to 0. It would not give me exact 1 or 0 value. It would give me decimal value, right? So that would I consider as a probability. So let me know if there is any confusion in this section. Otherwise, let's see what would be sigma z and what would be 1 minus sigma z. Let's see that. So sigma z probability y is equals to 1 would be sigma wx plus b, and I can write down this as 1 upon 1 plus e to the power minus wx plus b. Now if I want to find out probability y is equals to 0, 1 minus sigma wx plus 0. So that means 1 minus 1 upon e to the power minus wx plus b. So if I'll solve this, I'll get this as e to the power minus wx plus b upon 1 minus 1 plus e to the power minus wx plus b. So now you can see that what is my decision here. Y is equals to 1. if this sigma z value is greater than 0.5, so can I say that if sigma z is greater than 0.5, then we have then we have the output y cap would be 1, not y cap, then the output, final output would be 1. If sigma z is 0.5, then output is 1. If sigma z is less than 0.5, then output is 0. So now you can see that uh, what we have started, we have a data point x, and I have to classify that either it is going to 1 or 0, right? So what we have done, we have multiplied it with weight, and then multiplied with, and then added with the base, right? And then I have gone through this function to the sigmoid function wx plus b. Then it gives me the probability that either it is 0.6, 0.6, 0.7, 0.8, it would give me any number. If it is greater than 0.5, then output is 1. If it is less than 0.5, then output is 0. Because then probability of y would become greater than 0.5. Y is equals to 0 would become greater than 0.5. Right? So let me know if there is any confusion in this. Then we'll move forward. Then we'll see the differentiation of sigmoid function. Because why it is important, that differentiation of sigmoid function? Because at the end we have to minimize the error, like we have done in linear regression, right? We'll take all the output we already have, and then we'll take the output which we get, predicted output and actual output, take a difference of that, and then we'll minimize that error. We have to do that, right? Like we have done in linear regression. This slide, mathematics is important with respect to exam point. Yeah, because your gate exam is basically based on calculation. If you will see IISc exam as well, they have asked you some numerical questions, like they have asked about the Gini impurity, or information gain, or they have asked about the cluster point. So they have asked the maths behind the algorithm, right? Because you can't code here, so they are going to ask the maths behind that. So I'll share some questions with you. We'll solve together some of the questions, so that you would know how to actually solve questions based on machine learning, right? What kind of questions you can expect, right? So we have discussed that sigma z is equals to 1 upon 1 plus e to the power minus z, and z is what? Wx plus b, right? Z is what? Wx plus b. So sigma of z, can I write down this as 1 upon 1 plus e to the power minus wx plus b, right? Because now can you tell me that what are the parameters here in this equation? What are the parameters? If I have to take a derivative, w and b are the parameters which I have chosen myself. X is already given, sigmoid function definition I already know, so w and b are the parameters, so I have to differentiate with respect to that. Again, likewise in linear regression, we have find out the value of w and b, so that we'll get the minimum error. So here we have the same thing. So let's see what would we get. Del sigma z by del w. So I have to differentiate it. What would be the differentiation? 1 plus e to the power minus wx plus b. I'll take a quotient rule, denominator square, and then I have a minus 1 here, and differentiation of this denominator, that would be 0 minus e to the power minus wx plus b, and sorry, plus 0 and then plus, and the differentiation of minus wx plus b with respect to w, we'll get minus x. So this is a differentiation, right? So if I'll solve this, what would I get? Minus minus plus x, so e to the power minus wx plus b, and 1 plus e to the power minus wx plus b. So guys, it's important that how you are writing this function. Now can I write this function as, because I have to simplify it now, right now it's too complicated. So what I can do here is I can write down e to the power minus wx plus b upon 1 plus e to the power minus wx plus b, and can I write down this as 1 upon 1 plus e to the power minus wx plus b, and then I have a x value here. So what I have done, this whole square I have break down into two values, right? You can see here. Now for this one, I can write down this as 1 upon 1, 1 minus 1 upon 1 plus e to the power minus wx plus b. I'll get the same answer. You can check by yourself. This is all the calculation, right? So you will get this value, and here I have 1 upon 1 plus e to the power minus wx plus b and x. Now you will ask that why I have done so much of things, because you can see that the derivative of sigma z with respect to w, what would I get here? I get this value as 1 minus sigma z and sigma z into x. So this is a derivative of sigma z with respect to w. Just let me know in this derivative, anybody have any problem how we have find out this derivative? Just let me know. So you can see that this sigmoid function derivative, we get this 1 minus sigma z into x. Similarly, if you will derivate, this is what? This is del of sigma z with respect to w. And now if you will find out a derivative with respect to b, you will get the same thing. Instead of 1 minus sigma z into sigma z, you will not get x value here, because it is, you can solve by yourself. Ma'am will also explain multi-class classification as well afterwards. Yeah, Rajveer and Yuvraj, if there are more than two classes, then it would be multi-class, and then we'll use softmax regression. We are going to discuss that in this session, right? So we'll discuss that. Right after this, we'll discuss softmax regression as well. Right, so these two derivatives I got. Just remember this, because I am going to use that later. Right, so just remember these two formulas. Right, okay. Now let's see further. And sigmoid function has this property that 1 minus sigma x is equals to sigma of minus x. Right, you can justify by yourself. Let's find out 1 minus sigma z. What is 1 minus sigma z? 1 upon 1 plus e to the power minus z. Right, so if you will solve this, you will get e to the power minus z 1 upon 1 plus e to the power minus z. And if you will find out sigma of minus z, sigma of minus z would be 1 upon 1 plus e to the power minus z. That would give me e to the power z. And if I'll multiply e to the power minus z, numerator and denominator, you will get this. You would get this e to the power minus z plus 1. Right, so that's why sigmoid function has this property. So we could have expressed probability y is equals to 0 sigma of minus wx plus b. Now you can see that previously I told you that probability y is equals to 1 is sigma of z. Right, probability y is equals to 0 is sigma of 1 minus sigma z. So can I write down this as sigma of minus z? Both have the same meaning. Right, so there is no difference in that. Now next thing is decision boundary. I already told you that this decision x, if this probability, if this sigma z value is greater than 0.5, then I'll make a decision 1, otherwise we'll make a decision 0. Right, that thing I already told you, that how would you take a decision in this. Right, now next thing we have is, let's take one example that how would we work on a classification problem using logistic regression. So let's say if we have given a paragraph, we have to check in that paragraph sentiment analysis. We have to do a sentiment analysis that this paragraph has a positive sentiment or negative sentiment. So we have taken 6 features for that. Right, so 6 features. So when we have a single feature, I have written down w into x plus b. If I have a multiple feature, let's say 6 feature, then I'll write down w1 x1, w2 x2 plus w3 x3 and w4 x4, w5 x5, w6 x6. This is same as linear regression. And plus b. This is plus. Let's make it correct. This is plus b. So now you can see that this would become in linear regression as well. When we have multiple number of features, we write like this, everything else will be same, right? So we have 6 features here: x1, x2, x3, x4, x5 and x6. X6 count positive lexicon words. Lexicon words, that means collection of words. So positive words, if those positive words belongs to the document, it would count. So we have in that paragraph, a particular paragraph is given to me, 3 positive words are there, x2 is 2 negative words, and x3 counts if there is no belongs to the document, then we have this x3 feature 1 value. And x4 value count pronouns, first and second pronouns belongs to the document, so we have three pronouns in that. And x5 gives me 1 if exclamation marks belongs to the document. And x6 take the value log word count of a document. So it would count how many words are there in the document, and it would take a log of that, right? It is already given to me, and log 66, in that paragraph I have 66 words, so log 66 is equals to 4.19. So I have given the value of x1, x2, x3, x4, x5 and x6. And I have to do a sentiment analysis, right? So I have to find out the weights and bias. So let's suppose I have given the weights. The 6 weights corresponding to 6 features are 2.5, minus 5.0, minus 1.2, 0.5, 2.0, 0.7. Right? These are the weights given to me, and b is equals to given to me 0.1. Right? That is given to me. Right? These weights are given. Can you find out the value of z value here? Okay. Just a minute. Yeah, now it gets clear. Yeah. Can you find out wx plus b? What would we get? Wx plus b would be w1 x1, w2 x2. So you can find out the z value here. So let's see how would I find out the z value. So if I'll move here, so wx plus b would be, this is w, 2.5 minus 5.0 minus 1.2, 0.5, 2.0, 0.7. And these are my x value. 3, 2, 1, 3, 0, 4.19. I can write down this as a vector. I already told you in linear regression, when we have multi-linear regression, right, then I can write down this uh, uh, as a vector, right, and plus b, right? So we, on solving 2.5, so it would become 2.5 into 3 plus minus 5.0 into 1 plus minus 1.2 into minus 1.2, oh this would be 2, sorry, and this would be 1 plus 0.5 into 0 plus 2.0 into, sorry, that would be 3 into 0 plus 0.17, 0.7 into 4.19, 0.7 into 0.7 into 4.19, right, plus 0.1. Now I can solve this. On solving, they get this value 0.833, this. So we 0.833. So I am writing here that w into x, w dot x plus b, we get as 0.833. Now I have to find out sigma of this value. So sigma of 0.833 would be, sigma of 0.833 would be 1 upon 1 plus e to the power minus 0.833. Now I can find out this value using calculator. Right, I can find out this value using calculator. On calculator you will solve this, you will get this 0.70. Right, similarly I can find out 1 minus sigma wx plus b. For probability y is equals to 0, we'll get 0.30. So you can see that y is equals to 1, that means positive sentiment. So 0.70 is my positive sentiment. So I can see that given paragraph which is given to me is positive. And also one thing, if you will not notice here in this uh, x2 feature is a count of negative lexicon words. That means count of all the negative words we have in the document, that is 2. And corresponding to 2, corresponding to x2 feature, I am getting minus 5.0 weight. right? Weight is negative. So weight is negative means for the negative feature, we are not giving so much emphasis on this one, right? So that means there are more positive words, because for positive words weight is given 2.5, that is positive, so it is making it greater, and it is making it less, right? It is making giving, so that's why we get the positive sentiment instead of negative sentiment. So this given paragraph which has all these features is of positive sentiment. I'll classify that paragraph into positive sentiment. Let me know if there is any confusion in this example. So this example tells you how to approach logistic regression calculation. Okay, so let's move forward. Now next thing we have here is loss function. So guys, previously in linear regression we all have discussed that what we have done, we have a actual, for loss function we have a actual value and we have a predicted value y cap, and I have taken a difference of that, right? And that would be my error. But you know that in this case my actual value is 0 and 1, and predicted value is probability, right? Point 0.7, point 0.8, these kind of numbers I am getting using sigma z, right? I am later I am doing all the mathematics that it is greater than 0.5, then I'll consider it 1. If it is probability is less than 0.5, I'll consider it 0. That is different thing. But the output after sigma, I'm getting these kind of numbers. So that means the loss function, this loss function does not exist. And I'll tell you one more thing here, that in that particular loss function, what we have done, because we have some linear data y minus y cap square upon let's say 2m summation I varying from 1 to m, this is this kind of a function, right? This is a convex function. So when we have applied gradient descent, we reach to a sorry, when we have applied sigmoid function, then we have when we have applied gradient descent, we reach to a minima. But when we talk about this sigmoid function, sigma of z, right, this kind of a function is a this it is not convex. That means we have so many local minimas here, right? We have too many local minima. So that kind of loss function which we have used in linear regression does not work for logistic regression. So we need a new kind of a loss function. So how would we get that? Let's see. So this is my loss function, minus y log y cap, 1 minus y log 1 minus y cap, right? Minus of y log y cap, 1 minus y log 1 minus y cap. Let's understand this loss function. Let's say if predicted value is 1, sorry, if actual result is 1, then this L function would become, if y is 1, then it would become log y cap minus log y cap, and this would become 0. Sorry, this would become 0. Minus log y cap would be my error. And if y is 1, if y is 0, this value would become 0. So y is 0, it would become minus log 1 minus y cap would be the error. So you can see that this loss function giving me error, that minus log sigma z would be my error if y is equals to 1. Log sigma z, why log sigma z is error? Just understand this. I am getting predicted value, I am getting actual value 1. So if I am not getting the output 1, then we'll get the error value log sigma z, because sigma z is giving me the probability for giving the value 1, right? So that's why minus log sigma z would be the, and if I'll go in detail, there would be a maximum likelihood. You would study in statistics. With that we get the whole explanation that how do we got this function in detail. Okay, Sadia is asking what is the difference between cost function and loss function. Loss function basically gives me error for one particular value. For cost function, I'll take a sum over all the errors. cost function, that means complete error, total error, as you can see here, right? So now so cap comma y cap is my predicted value, y is my actual value, so it would become minus y log sigma wx plus b minus 1 minus y 1 minus log sigma wx plus b. This would give me my error. And cost function would be, if I have m values, if my data set has m number of values, it would become 1 by m summation I varying from 1 to n l y cap I comma yi. Just let me know if there is any confusion till now in loss function, because now the next step, what would be the next step? Just tell me, guys, what would be the next step from this point onwards? What would be my next step here? Next step would be that how would I minimize this cost function, right? And to minimize, I have learned that gradient descent help me to minimize that function, right? So for gradient descent, I have to work on w and b. So let's see how would I do that. Right now, gradient descent implementation again. So for gradient descent implementation, what would I do? I'll write down w is equals to w minus alpha. Alpha is my learning rate, del j by del alpha. Similarly, sorry, del j by del w. I told you the concept of gradient descent, and then b is equals to b minus alpha del j by del b. This would give me my gradient descent, but I have to find out del w, del j by del w, del j by del b, right? So let's see. So instead of del j, let's write down here right now l. Why I am writing l? Because I am working on one feature. Either you can apply summation as well, it does not matter here. So I am writing ma'am, can you explain about maximum likelihood estimator, because it appeared in sample question paper as well? Okay, we'll discuss that as well. We'll discuss that as well. So we have ly comma y cap comma y. So I can find out del l by del y. This is a statistics topic, but we'll discuss it later when we'll get time. Sorry, del l by del y, we have to find out del l by del w. Right, I have to differentiate with respect to w. So minus sign, let's keep it outwards, and log sigma wx plus b. Okay, let's not write down, just a minute, let me write down this in terms of z. Can I write down this as ly cap comma y minus y log z plus 1 minus y log 1 minus z, right? Same thing, z is, sorry, instead of z I have to write down sigma z log sigma z, and I can write down here 1 minus sigma z. Right, so now can I write down del l by del w? Right, I have to differentiate it. Let's keep minus sign outside, and let's differentiate with respect to w. Y is a constant because it is a actual output. Let's differentiate log of sigma z. So log of sigma z, differentiation would be sigma z, and then I have to differentiate sigma z using chain rule. First I'll differentiate log, so this would come to the denominator. Now differentiate sigma z. So I told you, if I'll differentiate sigma z with respect to w, what would be the differentiation? Sigma z 1 minus sigma z into x. This would be a differentiation. Right, now it is complete here. Now 1 minus y, let's keep it as it is. Log 1 minus sigma z, its differentiation would be 1 minus sigma z, and then differentiation of 1 would be 0 minus sign, and then sigma z differentiation. Sigma z, and then we have here 1 minus sigma z, and then we have x value here. Right, so this is all this is the complete derivative of our ly function. Right, now the sigma z and sigma z cancel, 1 minus sigma z, 1 minus sigma z cancel. So if I'll take x common, let's take x common, minus x I can write down this as y minus y sigma z, and then I can write down this as minus sigma z, and then I can write down uh, minus minus plus sigma z y, right? So this y sigma z and y sigma z cancelled, and I can write down this as y minus sigma z. So this is the differentiation, del L by del W. This is the differentiation, and I can also write down this as del L by del W as, okay, we have one outside sign, this is minus. Yeah, so we can write down minus x, or I can write down this as x into sigma z minus y. So it's up to me what I want to write, right? If I want to take this negative side inside. So that's how we'll get the differentiation of loss function with respect to W. Similarly, if I'll find out, guys, if you will find out differentiation with respect to B, so you do not have the x value here, everything else will be the same. Sigma z minus y. You will get this derivative. Right? So let me know if there is any confusion in these derivative. So now to improve W and B, what would we take? We'll take some initial value for W and B, and then we'll find out del L by del W and del L by del B, and then we'll change the values. We'll update the values again and again. Right? So let me know, guys, if there is any confusion in this. Right? Just let me know, guys, if there is any confusion. So now we get this. Let me write down here, because I'm not going to write it again and again, and I'm going to use it in the example. So here W minus alpha del L by del W is x sigma z minus y into x, and this would be W minus alpha sigma z minus y, right? This would be my derivative. Now let's erase this. Okay. Yeah. Okay, so let's move forward. So we have one example here which we are going to use. So you can see that now we have taken a simplified version which we have done before. We have taken only two features: count of positive lexicon words 3 and count of negative words, that is 2, right? And the correct output we already know is 1. Now I want to update the values of W0 and W1 and W2 and B, because we have X1 and X2 features, two features, so we have two weights, W1 and W2 and B. I have all by myself, I have taken the value 0. I'll see that how gradient descent works, and learning rate alpha I am taking 0.1. Rajveer, you can't expect, we can't expect so much calculation, but we should know that what kind of, how calculation works, because they would take a small part and then they would ask the question, right? There might be a possibility. So we know how these things work, right? How algorithm works. We should know that. So now x1 is 3, x2 is 2, w1, w2 I already know is 0, alpha is equals to 0.1. Now I want to know that how these w's are updated, right? So I'll find out del L by del W. Del L by del W. So I know that del L by del W is sigma z minus y into x1, because it is, we have three features: del L by del W1, del L by del W2, sigma z minus y x2, del L by del B, that is sigma z minus y. So let's find out first sigma z. Sigma z would be, here I can see here that, just a minute. Yeah, here z is equals to w1 x1 plus w2 x2 plus b. So w1 w2 b are 0, so z would be 0. So I can write down sigma z would be 1 upon 1 plus e to the power minus 0, that is 1 by 2. You will get 0.5. So I can write down here 0.5 minus 1, and x1 is 3, so we'll get minus 1.5. Del L by del W2, that would be 0.5 minus 1 into 2. That would give me minus 0.5 minus 1.5 minus 1, and then we have this 0.5 minus 1. So we'll get this value minus 0.5. So you can see that del L by del W1, del L by del W2, del B I got. Now the updated W1 would be W1 minus alpha, this del L by del W1. Right, so previous W1 was 0 minus alpha is 0.1, and alpha del L by del W1 is minus 1.5. So you can see that 0.15 would be my updated W1. Similarly, I can update W2. W2 would be W2 minus alpha del L by del W2. Right, so it would become 0 minus 0.1 into minus 1, that would become 0.1. And B would get updated to B minus alpha del L by del B. So B is what? B previously was 0 and 0.1, and we got this as minus 0.5. So we get the value 0.5. So you can see that we have initially started the value W1, W2, B as 0. Now it gets changed to 0.15, 0.1, 0.5. Now I can again work on this algorithm from the start. I'll take W1, W2, B as 0.15, 0.1, and 0.5. And then I'll again find out del L. First I'll find out Z, then sigma Z, then del L by del W1, del L by del W2, del L by del B, and with corresponding to that I can find out this. So again and again I can update using gradient descent, and you can see that because I am getting this y is equals to 1, so count of negative lexicon words would be this. For this W2 weight would be negative value if you will update again and again. So it's not possible for us to calculate all these things by ourselves. That's why we use computer. So that's how logistic regression works. Just let me know if anybody have any confusion till now in logistic regression. Just let me know. Guys, if you understand it, just let me know in the chat section. If anybody have any confusion, then let me know that as well. Guys, I'm waiting for you to let me know anything. Okay, so okay, let me explain it again. That we got, first of all, what we have done. Let me tell you how we have proceeded. Step one, I have find out a value of z, then I have found out sigma z, right? Corresponding to that, I have find out this step two, in which I have find out del L by del W1, del L by del W2, del L by del W, del L by del B. And then in the last step, I have updated the values of W1, W2, and B. Right, so I have started with the value of w1 w2 b as 0. Right, initially I have taken these values 0, then I want to update it. Like, what, how does gradient descent work? This is a function. Let's say, if let's suppose I am here, so I'll move to this place, then I'll move to this place. So what I have done, I have at this place where w1 w2 b are 0, then I have moved to this place, which is where I got the weight 0.15, 0.1, and 0.5. But I have to reach at this place, so I'll update it again and again. So how do we update it? By proceeding with these three steps. First, I'll find out the value of z, sigma z, then these partial derivatives, which we call as gradient as well, and then later on we'll find out the values. Sadia, I told you na, why we should update the values, because we know that, because I have taken this W1, W2 B by myself. I told you in linear regression as well that, let's say if I have some data set and I want to find out best fit line, so I do not know what would be W and B, right? So this line can be best fit, this line can be best fit, this line can be best fit. So how do I find out a best fit line? To get the to optimize the loss function for W and B, and we do that using gradient descent. We'll update again and again the values of W and B. Do you get it, Sadia, now that why we should update the values? Because we have to reach to the minimum value for loss function. That's why we want to minimize the error. Right, updating means that I am trying to reach for this function, this loss function. Loss function is basically I told you that what was the loss function. W1, W2 and B are the only assumptions, right, Sadia? These three are the only assumptions. So if it is clear, so that's what we do in logistic regression. What we have done, first we have find out a line Wx plus B, then we have pass through a sigmoid function that would give me the value between 0 and 1, and then these values 0 and 1 gives me the probability that either I have a 1 value or 0 value, positive sentiment, negative sentiment, A or B, right? These kind of things, right? But next thing is, if I have a multi-class, right, I have a categorical output. First, before I have taken binomial output, there may be a binary output. There may be a possibility that I get multiple outputs, A, B, C, D, first, second, third, fourth ranking. How do I work on that? Let's see. For that we have Softmax regression. Multi-class, we call that as multi-class classification. Sometimes we need more than 2 classes as our output. Then how do we work on that? In such cases we use multinomial logistic regression, also called as Softmax regression. Right, now what we do in this, so as you know that in this Softmax regression, let's say we have output, let's say we have the output 1 2 3 4, 1 2 3 4 are my outputs, right? First of all, Z would be same. Z would be W into X plus B. Z would be like that, W into X plus B. Then in this case, can I find out Z1, Z2, Z3, Z4? So for the first class, I'll get Z1 is equals to W1 X1 plus B. Z2 would be W2 X2 plus B, and Z3 would be W3 X3 plus B, and Z4 would be W4 X4 plus B. Right? Sorry, B1, B2 basis would be again same. B, sorry. B1, B2, B3 and B4. Then Zi's would be same, would be different. Then I'll find out this A1 value. A1 value would be, let's just see one. A1 value would be e to the power Z1 upon e to the power Z1 plus e to the power Z2 plus e to the power Z3 plus e to the power Z4. Right? And this A1 gives me the probability of output y is equals to 1, such that x1 is given to me. Or let's say x vector, not x1, because it is multi-class. So we have this x, probability y is equals to 1 x. And then I can find out A2. A2 would be e to the power Z2 upon e to the power z1 plus e to the power z2 plus e to the power z3 plus e to the power z4. Right, this would give me probability y is equals to given x. Right, similarly a3 e to the power z3 e to the power z1 plus e to the power z2 plus e to the power z3 e to the power z3 plus e to the power z4. This would give me probability y is equals to 3 given x, given the initial x value. Right, now I can have four types of output. Similarly, I can write for a is equals to 4. Right, so we'll get all these probabilities. For a equals to 4, it would become e to the power z4 e to the power z1 plus e to the power z2 plus e to the power z3 plus e to the power z4, and this would be probability y is equals to 4 given x. Now let's say I get the a2 value as 0.6. So you can, or let's say it gives me this a1 value I get 0.2, a2 value I get as 0.4, a3 value I get as 0.3, a4 value I get as 0.1. So you can see that a2 value is greater for all the other values. So I can say that my output value is 2. My output value is 2 for that particular x value. Thanks, Sadia. My name is Sakshi. Right, so the a2 value would be, if a2, so we'll see that out of these four values, which of the value is greater. Right, and that would be my final output for that particular input point. So let's say if I have given a particular x, I'll find out a z1 value, z2 value, z3 value, z4 value, right, corresponding to that x1, x2, x3, x4, and then I'll get my I can find out these probabilities, and the higher the probability, that would be my output. So let's x initial input would be same, guys. X would be same. X would be same. Right? It would not be x1, x2, because initial point is single point, or if it is a vector, then otherwise w1, x1, it would become a vector. Right? So that is my softmax regression. So let's say if I have n possible outcomes, so I can say that, and one more thing, a1 plus a2 plus a3 plus a4, that would be equal to 1 always. All the probability sum is always equal to 1. We know that because of probability as well. Similarly, in this case, if let's say if I have k total outcomes, so I can write down e to the power zj upon e to the power z1 plus e to the power z2 plus e to the power zk, and j varying from 1 to k. So the higher the value of aj, that would be my output. I can write down like this. And guys, if I'll talk about log function, loss function, can anyone tell me in this case what would be my loss function? Can anyone tell me what would be my loss function? Previously, we have seen that in logistic regression, when we were discussing binary classification, then we have discussed that loss function would be log y 1 minus, sorry, there. So loss function was minus y log sigma z 1 minus y log 1 minus sigma z, and I can write down this as y cap as well, y log y cap plus 1 minus y log 1 minus y cap. So we have seen that when y is equals to 1, predicted error would be, loss function would be, this is loss function. When y is equals to 1, this value would become 0, so error would become minus log y cap. When y is equals to 0, error would become minus log 1 minus y cap. And y cap is what? Y cap is a value of sigma z, which we are getting. So in this case, what would loss function would become? when I is equals to 1, so let's say we have the outputs by 1, 2, 3, 4 up to k. When y is equals to 1, error would be minus log a1. Y2 would be minus log a2. Yk would be, if y is equals to k, then the error would become log ak. So you can see that for y is equals to 1, we are getting log y cap, and y is equals to 0, log 1 minus y cap, because these are the only probabilities when we were discussing about binary classification. Either it is y cap or 1 minus y cap. Now in this case, when we have y varying from 1 to k, we have the probabilities minus log a1, minus log a2. We have a1, we have probabilities from a1 to ak. So we have to consider all those things. So we get this minus log a1, minus log a2, up to minus log ak. Right? The smaller the aj value, the higher the error, the larger the loss. Right? Just let me know if there is any confusion in this loss function. Right, Rajvi. This we call as cross entropy as well, and we'll discuss cross entropy when we'll discuss information gain and decision tree, all these things in detail. But right now, let's remember that. So that's how this softmax regression work. Sum of the negative log of all the probabilities. No, you can't take the sum like that. Like previously as well, when we have taken the loss function, we have taken minus y log y cap 1 minus y log 1 minus y cap. Right? So you can't take the sum. Right? At one time, only one probability, one error is possible. Okay, so that's all I have for logistic regression. We are going to discuss more classification algorithm in the next session. So you can tell me if there is any doubt, cases, just don't understand. What are you saying? Right, we'll have the cases if y is equals to 1, y is equals to 2, y is equals to k. If I'll go for the example, there would be a lot of calculation. So just remember the concept. Yeah. So in the next session, we have covered linear regression and logistic regression. In the next section, in the next session, we'll discuss k nearest neighbor, and we'll discuss naive Bayes classifier algorithms. Okay, we'll discuss in detail, and we also work on the examples based on that. So I hope it is clear. You can tell me if there is any confusion at all. Otherwise, that's all for this session, guys. Thank you. And also, one thing again, I want to let you know about our 390 challenge. In this, if you will take a course from 1st January to 31st of January, you will get a refund of 90% of the amount of the course which you have paid for, if you will complete 90% of the course in 90 days. Can we get the printed notes of machine learning? Uh, how do I share the printed notes? Okay, from the next session onwards, I'll try to add that slide in the description box. Otherwise, you can go through the videos. I do not have write much of that, because if I'll see on the board, I have erased all the things. I just have these things. You can go through the videos and you will get all the things here. Okay. Typed, I haven't saved it because I have written on the board and then I have erased it. So I think that would not be possible. So guys, I'll suggest you that you would make your notes while learning. Okay. Yeah. So that's all from my side, guys. Thank you. Thank you so much for joining.